Good morning. I would like to welcome you to this beautiful sunny day, to beautiful Detroit. I'm Boris Dragunsky, and I will be co-moderator, session moderator, and I want to welcome you again. I hope we'll have a nice, lovely discussion. Our session actually dedicated to a work of Committee 364, which is rehabilitation of structures. And this committee likes to take controversial issues and frequently asked questions, FAQ, and develop answers and also develop discussions. This morning we'll have several presentations given by people with a lot of experience in various fields involving rehabilitation of existing concrete structures. Rehabilitation of concrete structures, I think it's an issue which sooner or later any structure which is built will go to a rehabilitation or repair or something of that nature. And experience of people who work in the area of rehabilitation quite different from the experience of people who are involved in new design. And it's very important for people who are designing new structures, I think, also to understand the future performance of the structure, its durability, its performance, and also how the structure would be rehabilitated, would be maintained for years to come. This is why we invited you and invited members of our committee to present different topics which stem from facade repairs to parking garages to different materials. Our first presentation will be given by Alex Vaysburd. Although most of you know him or of him, I like to just to recap. Vaysburd is a principal of Vacon Consulting Company, formerly with structural preservation. He is embarrassed to say that he has 40 years of experience, most of that of positive experience, working in the rehabilitation of structures, concrete technology, and forensic engineering. Alex was involved in construction of a number of structures as well as their rehabilitation. I also like to mention that unfortunately Alex we don't have a handout for this presentation. However, people who are interested in this presentation, I would like them to refer to Corps of Engineers report, REMR 1998, which is a report on bond evaluation using different methods and procedures. Again, it's REMR 1998, Corps of Engineers. And without further ado, I'd like to present Alex Vaysburd. Thank you. Also, I would like to mention this session is being recorded and taped. Thank you.
Good morning. It's being recorded not by CIA or KGB, so feel free to ask questions. Boris announced that I have more than 40-year positive experience, so I have also negative experience. Okay, now everything is fine. Let's go. Actually, just a reminder, what is a concrete repair? It's a composite system. In our understanding, in general, that it consists of 3 phases. And concrete repair is a composite system of composite materials, different composite materials. Oh, is this going to be?
I can't hear you, Alex.
Oh. So this composite system of concrete repair generally exposed to different type of loading. Structural loading in case of structural repair, and all kind environmental loads, interior, because we are dealing with structure with certain already established interior environment, and also exterior. So quite a complex combination, quite a complex structure, which is in fact much more difficult to analyze than new construction. In addition, that it is not a static system, it's a very dynamic living system, if you want to say this way, because everything is in constant evolution, everything is changes based on temperature, humidity, all kind of gradients, and a change in chemistry also inside the system. So when we are speaking about any kind of composite system, which concrete repair definitely is, and on the step of hierarchy, probably it's on the top because it's a very complex one. In any monolithic or structure or composite system, one of the necessary requirements for success, let's put it this way, success, I hate to say durability or structural performance, but let's say success of the project is achieving an adequate bond. What is an adequate bond? It is how it is achieved by proper conditioning of the concrete, and in case of exposed reinforcing substrates, and absence of let's say a plane of weakness. And very important from the point of view of field operation to achieve an intimate contact between the repair material, which is always, except a few known exceptions, it is in semi-liquid phase, which is going through all kind of transformation, or including volume changes, all kind of stresses are occurring at the interface between this semi-liquid material and man-made stone, which is a substrate, and all these stresses actually are occurring on the bond line. So, but what is the bottom line? It is like written here very clearly, long-term performance in severe environment. Or speaking in general, because we have to cover not only a case of severe environment, we have environments which in some reason are mild or even very nice environments. What I call it is lasting interfacial coexistence. It's like in a marriage, you know. It's very similar, because unsuccessful repairs, they are ending up with a divorce between old and new. Why I'm putting this nasty slide and nasty statement, which you can read, I'm not going to repeat it, kind of, it's really a little bit nasty, because this is, in many cases, what is very present today, and it present for a few decades in our industry. We are engineers, or whoever is coming up with requirements, certain quality requirements, we are coming with numbers. And it is an endless list, which if I'm going to start to speak about it, I'm not going to give a chance another speaker even to say a word today. But just a few examples. Chloride threshold. We love formulas. We love numbers. When we have a number, we always have an excuse for something, for analysis, for common sense. So in case of concrete repair and testing the bond between new and old, the bond in this monolithic system, you'll find out that guidelines of ICRI, ACI 503, specification, and also report and many other documents and specifications we are writing, including me, we are writing numbers. It should not be the bond after the contractor finishes the job or at whatever age, should not be less than for 100 PSI, 150 PSI, 200 PSI. We love numbers. And in many other cases, it's an endless list. But we are forgetting that we are making so many assumptions. And then we want to keep it exactly to some formula or to some numbers. And this is very typical for this situation where we have to achieve a good bond between concrete repair material and existing substrate. So actually, this is an issue of this presentation, to clear up a little bit the issue and to take a look on it under different angles. What are we talking about? Well, of course, this Thomas's theory on the composition of the universe, and since we are all in this universe, so it clears it very much why we are following these rules of numbers, fluoride threshold, not exceed 1,000 columns on chloride, accelerated test on chloride penetration, so 1,000, everything before 1,000 is okay, after is a bad material. Nobody who knows about any case when this specimen had a crack as they measured. Not a single specimen when you are checking the permeability has a crack. It's always a very nice one. So it does not represent any serious issue. It's just confusing the issue. The same here. Very often we have problem, and I'm guilty as anybody else. So a few engineering consideration about concrete repair, as you well know, or if some people just they have to be reminded, removal of unsound concrete. And it is not only unsound, as you well know, in order to keep certain common sense geometry and sometimes to undercut the rebars, which industry is pretty much following now, thanks God. So you have to remove also sound concrete. Cleaning, very important opening of the substrate material pores to receive new materials, and you really have this transition zone, which very seldom people are talking about. Cleaning and repair of reinforcing. Also, you have to consider such issue, which is, by the way, not as carbonation, because as you well know, carbonation only affects the protective ability of the concrete cover to protect reinforcing steel, but otherwise it improves the quality of the concrete and densifies it. But densifying it kind of makes, changes the pore system, make it denser, and it affects negatively in many cases the bond, in some cases significantly, in some insignificantly, so it may be not an issue. And of course, presence of chloride contamination has nothing to do with the bond issue. However, it should be considered, because when you are removing concrete, chasing the bar until you are coming to not corroded bar, you definitely are affecting the bond between surrounding healthy concrete. So another issue is just simply to have no contamination with dust on anything, and it is very high-tech testing system. Take your hand and just see whether you have dust on it or not. Another thing which is affecting significantly bonding, and why we are very often not achieving a good bond, because by impacting it with mostly electrical or pneumatic chipping hammers, we are of course damaging the surface. And this is a lot of, let's say, here you see under serious magnification, but it is not on macro level usually. On macro level, it's almost impossible after the final cleaning, but it is on micro level. You have all this horizontal fracture or micro cracking and all imperfections which very much are affecting the development of bond and strength of the bond. So which is shown here, it is shown bruising, and well, usually if you are not barbarically removing concrete, doing it so it doesn't affect probably more than 1/8, 1/4 of an inch of the concrete substrate surface. So evaluation of the concrete surface before you are going to apply the repair material, and I'm going to leave for this discussion only one method. There are two issues which can definitely affect the development and durability of the bond between old and new. And of course, I'm not going to speak about issues which are simple, or any kind of foreign materials, bond breaking materials, but an engineer, a contractor has a tool today, which is a so-called direct pull-off tensile strength test, which initially actually was used for evaluation of the condition of the concrete, of the strength of the concrete, pull-out strength of the concrete. This, if you have any doubts, engineer or a contractor, maybe the existing concrete by its nature is not adequate to develop certain bond, 200, 300, whatever PSI bond. It is better always to be on a safe side and check by this pull-off test this strength of the prepared surface before it is receiving the repair material, in order, if you are not achieving it because of some problem, whether with existing material, whether with the workmanship of the contractor, you don't have later on to remove it. So this is actually schematically shown tensile pull-off tests. There are quite a few different devices in Europe and in United States which we are using to evaluate this tensile strength. Quite straightforward, quite easy, a very good concept. If you probably very well know and you understand the situations that actually the failure in predominant cases occurs not in tension in this system, it occurs in shear. Because when you have volume changes in a repair material which is being applied, as I mentioned, in semi-liquid conditions, so you have in one layer, let's say it is a layered system, you have compression, in another layer you have tension, and the stresses which are occurring at the interface actually it's shear. But still, over the year, the industry found that this is the easiest, more representative test for field evaluation. Several other tests which are being used, they are good or not very good, but for lab evaluation, which is a different ballgame. This is it's a lot of popularity, it's a very good test, but this test is not applicable without using brains, without using common sense. And we are experiencing a lot of anecdotal situations because we are using it just straightforward. And when I'm saying what people are using it in field, unfortunately, in all documents we have now, except maybe the ICRI document, which is now under publication, guide for concrete repair bond, nobody is explaining really what are the limitations of this very good test. So let's speak about this. This is another, it shows that you can do it in any location of the structure, overhead, vertical, very mobile, very easy to use. Very useful test. This is one of the devices. It is actually modified by structural preservation system device, which is being manufactured by Hilti. It is a less expensive device on the market. It was not designed on the purpose of bond test. It was designed for pull-out strength of anchors test, but structural modified it, and it is perfectly fine used in field. Now, in 1996, if my recollection is okay, U.S. Army Corps of Engineers published a study on bond test with using different repair materials and also different apparatuses, more sophisticated like German instruments and expensive, and apparatuses simple as I just show you, which is a modified Hilti apparatus. And what was done, it was actually just a little bit information on it, because as the chairman mentioned to you, if you're going to give me or Jim McDonald your business card, we can send you this report. 266 partial depth cores were extracted from the artificially produced repairs. What we had precast concrete slab. We filled the cavities with different repair materials. We studied a different issue, but after the first study was finished, as a continuation, we studied how to measure the bond, and actually the issue was not the bond developed numerically, but what are the deviation between different materials and also apparatuses. So 77 repairs, we also 9 different repair materials, 3 testing devices, which is German instrument. We used Swiss, which is probably the most popular in United States. I'll show you later on this device. DOTs are using it very successfully. And also we tested 3 different depths of drilling into the substrate, because it affects very much the results and the development of failure stresses. This is the slabs we were testing, for your information. Yeah, we had a very, very good quality control. You should imagine that we're going to speak about our industry. This was the case. This is Jim McDonald is checking it. We had 3 chiefs for each Indian who was working on it. So it was a strict quality control, which never have in field. Also notice that we never have in field such a smooth substrate, which we have here. And almost from all practical point of view, parallel the repair surface and the substrate, which we never have in field. So this is how with German instrument we were running the test. This particular is in Arizona. We also ran it in 3 different environments. One in South Florida, one in Arizona job site, and the third was in Chicago. And this is how looks not a very successful repair. Just to give you an example, you can see a very definite borderline between old and new, and I can assure you that this repair is not going to last. And also you can see when the failure occurs at the bond line, which in this case, this is where numerical this number in PSIs starts to work. And this is a very good repair, which is, you see two different materials, just you can judge it by the size of the aggregate distributed in cementitious matrix, but it is no borderline. It's very smooth transition. So this is what we are always trying to achieve, not always successful, but this is a goal. And when we are extracting this cores, and this is what we did for each particular this slab, we did 3 different pull-offs with each apparatus. So actually each slab had 9, since we were using 3 apparatuses, 9 of such holes, if you want to say. Now, before I'm going to speak about a very limited amount of results I'm able, based on time restrictions I have, to tell you, again, I want to return how we are judging with the numbers, how we are following the numbers. I'm trying over the years to understand myself and always asking questions. And if somebody in this room can help me, please, why is the bond achieved with, let's say, just throw out a number, 200 psi, better than 100 psi, only because it is larger? Actually, what is the goal in a bond, in this monolithic action? I think that the goal is, number one, to have a lasting transfer of stresses between substrate and between new material, between the repair. And second, as I mentioned to you, to have lasting bond. This is from durability and structural point of view. You need a lasting bond for the service life of this repair and overlay, lasting bond. If this is actually, if I'm right, so why 200 psi is better than 100 psi? Why we are stick so much to numbers? Isn't it true? And plus, I would buy this concept if somebody can show me that 200 psi in 25 can survive 25 years, and if you have only 100 psi, then you can fail in 15 years. So it's some way related, is some correlation between durability and this magic number, whatever it is. But it is not. There is no such correlation. In my practice, I've seen repairs with 300 psi, which is exceptionally good concrete on a very dense, high-strength substrate done. And they are not surviving because it depends on the environment. It depends on what loads, environmental or any other, are applied to it over the years. And also I've seen with 50 psi bond repair overlay system, which are behaving for a very long time exceptionally well. So it seems to me that we have to be very careful with these numbers. One guy from DOT, which I don't want to say, tried to convince me that saying at least where we have a higher bond, we have probably a better chance to survive for a design time for this repair or overlay. But well, I personally, I don't buy it. It's again, it's first guess. So what this test is actually, number one, it is a short-term property we are testing, because we know the bond only at the time when we are testing the bond. Now, it makes a very good test, which I think this is the main use for it, to evaluate the contractor's performance. At the time when engineer or the owner or whoever is evaluating if the contractor performed an adequate job, if it is a quality control, quality assurance test, you can evaluate that he did not fail to achieve certain bond. Later on, you just can test whether this bond exists and good enough in whatever, 5 years, 25. If you are alive in 80 years, you can test it, but nothing else. It does not show any correlation with longevity. So contractor did an adequate job. Now, again, the numbers. This is, you see on this, you see 11 materials, and each material was tested with each device. One yellow, another, I don't know, gray, blue, and red one. And let's just take the first material. For instance, you have with one device testing apparatus, you have 300 plus PSI. With another one, yellow, you have 200 plus PSI. So it is 200 PSI difference just due to the use of different apparatus in a very controlled field conditions. 100 PSI differential deviation in experimental project. Now, if I'll tell you another thing, that this test, which we call direct tensile pull-off test, is never a kosher, strict tensile test. In order to have only tension, you have to have only 90 degrees to the surface. You have your steel dolly to be centered. So it's all kind which is very difficult to get under field conditions. And by the way, in experimental, it was very different. If you're going to introduce an angle to which 2 degrees deviation from 90 degrees, you are introducing a bending moment. And it was calculated, one university did a very fine job, that 2 degrees deviation can give you 20% reduction in bond in PSI, which we are getting because of the bonding moment, because it's not only tensile strength. So we have deviation in apparatuses. We have deviation in the angle. Now, it's very difficult to apply smoothly the load. So we have so many things where we are assuming, yes, it's a tensile strength test, yes, it is this, yes, and after all, we are keeping the fellow contractor or engineer or consultant to this magic number, and we all are guilty. A few years ago, I had a project it is not in slides because it is a very, very secretive defense project was. I'm finishing, 2 more minutes. In Alabama, and which was a government, Pentagon, U.S. Army Corps of Engineers was involved, Westinghouse, Bechtel Power Corporation. So it's new construction, and it was a serious problem with a blast-resisting wall just constructed. So it was a question to remove and replace this wall, which is not finished yet, which cost $3 million extra just to remove and replace it, or try to fix it. It was difference of opinion, and we decided to come up with a pilot repairs to this wall. Again, I don't have slides of it because I'm not allowed to show it. So I as a consultant, I specified knowing that we have to demonstrate, and politics and media, TV was involved in it, so it was an awful project from many points of view. So what happens that when we did this pilot repair and to demonstrate that we are doing an excellent job and it can survive as designed, even a repaired one, I specified 200 psi. And all these parties, all this, on the meetings, they approved this number. Everybody loved, larger is better. So when we tested it, and I tested it myself, I was surrounded by probably 40 people with cameras, with everything. Instead of 200 psi, I got 187 psi. The guy who was from the US Army in charge of this project, in absence of engineers, practical engineers, gave an interview to TV and to local newspaper that probably the wall has to be removed and replaced because consultants and the contractor and US Army Corps of Engineers did not perform the repair to the specification. We had to remove it. No arguments, nothing. It was no common sense. Probably 15 people tried to explain that it is a perfect result, all variable, all imperfection considering 187 against 200, and main question I asked as a person who specified this dumb number, I asked what's the difference if it's going to be even 100? What difference it's going to make? So it was replaced with another one, and thanks God we got more than 200, so it was perfectly fine. Everything was the same. It's probably the spot we selected was luckier than the first one. This is why it's so important to use common sense. And we are keeping these procedures and these requirements all over. In documents of the industry, we are throwing out these numbers everywhere. This is why we have to understand the limitations of this very good test. This is a summary, actually, of the study, which a little bit, this is a very good test, quality control test. Test does not assure the main goal of durability, but it is a good quality control test, and it should be used with full understanding what it is for. Is it for? And recommendation. It is a preferred method. This is a recommendation not of this presentation, but of this study. Now, concerning the depth of drilling, in this study, which probably was the most extensive, best of my knowledge, study done, we found that extremely important is the depth, which everybody else who studied found, but we found that it should be deeper, for instance, than in European standards, which are existing. It should be 1 inch or half of the diameter of the dolly we are using. Then we have a much more realistic picture, nothing less effect of different factors and stress concentration than with shallow drilling into the substrate. Uniformity, which I was talking about. Now, another issue which I have, look on the last one, proper moisture content. We have a very good, very conservative approach. We are always recommending SSD condition to be on a safe side, which is actually saturated surface dry condition. But is it the best, and I'm going to finish with this, best condition for moisture condition before you are applying? Of course it is not. It is probably the safest, but not the best. How find out which one is the best? Sometimes it is bone dry, sometimes it is slightly sprayed. It depends very much on the material in the substrate. It depends to a large degree temperature and humidity, at this time. So what's the way? If you have time and money and you want really to achieve the best possible result, you have to run 3 different pilot projects on a small areas, 3 different moisture conditions, and then to go and run this pool of tests and find out which one is good. Now, if you're going to see 10-15% difference, it's irrelevant because it can be a deviation in apparatus and some other man-related factors in testing and repair. So it just see on, I would say, a substantial difference where you have 25-30% difference, you have to use it. So moisture conditioning is very important, but the only recommendation at this time can be a pilot project. What's the best way? If you don't have time, money, or agreement with the engineer or whoever owner, just saturated surface dry. Moisture conditioning, and thank you. I finished my presentation. You have time for questions.